In this skill, we will be simplifying square roots and cube roots with numbers and variables. So the difference from last week is now that we're adding in variables. And we kind of do it the same way we did with numbers. The square root of 4 is still 2, but the square root of a squared, remember when we do a square root, we're looking for the same thing multiplied by itself. So this is really the square root of a times a. Since I have two a's multiplied together, I can take one out. So the answer to this is just going to be 2a. For the next one with a cube root, instead of looking for pairs, now we're looking for groups of 3. If I make my factor tree for 8, it's 4 times 2, 2 times 2, we have 3 2's. That means the cube root of 8 is 2. We put a 2 out front. And then for x to the 6th power, this is 6 x's multiplied together. 1, 2, 3, 4, 5, 6. And how many groups of 3 x's do we have? 1, 2. And instead of drawing it out like that, I can just take x to the 6th and divide that 6 by 3, and I get 2 groups of 3 x's. So we get x squared. Okay, this next example has a little more going on. First, we're going to simplify the inside. I do my factor tree for 48. This is 4 times 12, 2 times 2, 2 times 6, 2 times 3. We have 2 pairs of 2's and a 3 that's going to stay inside. I already have 3b to the 3rd that I'm going to leave out front. I'm going to take out 2 2's, which means I multiply them together, I take out a 4. So it's going to be times 4. And then I'm going to leave some space for my variables. And then I put my square root, and I know that I have the 3 staying inside. Now I look at my b's. Inside we have b to the 4th. And there are 2 pairs of b's, or 2 groups of 2. So I put b squared outside. Now I look at c to the 7th, and how many groups of 2 c's do we have? We have 3 groups of 2 c's, so c to the 3rd, but this time there's going to be 1 c left over. 3 groups of 2 c's would only be c to the 6th, but we have another c that has to stay inside. And then I look at my D's, and we have how many groups of 2 D's? There will be 5. So on the outside, we're going to put D to the 5th. And now we simplify the outside by multiplying the part we took out by the part that was already out there. And I multiply 3 times 4, we get 12. B to the 3rd times b to the 2nd, I add the exponents and we get b to the 5th. And then c to the 3rd, d to the 5th, square root of 3c. And that's my final answer. Okay. And for this last example, same idea, but we have a cube root. So I make my factor tree for 81. That is 9 times 9. 3 times 3 and 3 times 3. So I have one group of 3 3's and a 3 that's going to stay inside. So I bring 1 3 outside, I leave some space, and then I keep a 3 under the cube root. Then for my p's, I want to know how many groups of 3 p's, and there would be 4 groups of 3. So we get p to the 4th. And then for the q's, how many groups of 3 q's are there? In 8, there would be 2 groups of 3. So we take out p to the 2nd, and there will be 2 q's. Sorry, that's a q. 2 q's left inside. And that's our final answer.